Welcome to Mathematical Economics Labs. In this class, I'll be showing you how to derive marginal concepts from total concepts. So, here are examples of marginal concept in economics. So we have marginal cost, that is MC. We have marginal revenue, MHAV. We have marginal product, MP. We have marginal utility, MU. We have marginal expenditure, ME. We have marginal propensity to consume, MPC. So assuming we are given total function, for example, total cost function, total product function, total utility function, total expenditure function, and consumption function, and we are asked to derive marginal concept in respect of this. So how do we solve this? Okay, generally, to derive marginal concept. So general rule is that to derive marginal concept from total concept, what we need to do is to differentiate, that is to derive a marginal concept from a total concept. Differentiate the total concept with respect with respect with respect to its independent variable. That is the general rule. General rule says to derive a marginal concept from a total concept. There is a total concept, there is a mistake here. Differentiate the total concept with respect to its independent variable or variables, as the case may be. So what does that mean? Meaning that if we, for example, we have example, let's say examples. Let's say we have total cost function. This is a total concept, which is given as, let's say, 100Q plus, let's say, 10Q square plus 500. This is a total cost function, and this is a total concept. So the rule says to get marginal concept from this total concept, we should differentiate this total concept, which total cost, with respect to its independent variables. What do we mean by independent variables here? That is the variable that total cost depends on. You can say from this function, total cost depends on Q. Q represents the unit of output produced here, or the unit of output sold, as the case may be. So we will follow this general rule to get our marginal cost. So what we need to do is to differentiate this. So our marginal cost will be equals to the TC over the Q. Okay, we differentiate with respect to the independent variable, which is Q here. So if we have to differentiate this with respect to Q, differentiate this, we have 100, then plus, bring down the power, that will be 2 times 10, that is 20. We are left with Q. Okay, now this is a constant, it becomes 0. So this is our marginal cost function. Okay, so meaning that to get marginal cost function from total cost function, what we need is just to differentiate the total. Which total? We should differentiate total cost function with respect to what? This key. So if any time we are asked to derive marginal cost from total cost, what we need to do is just to differentiate that total cost function with respect to the unit of output. Okay, if it is Q that is used in the equation, we differentiate with respect to Q. If it's any other variable, maybe X, Y that is used, we differentiate with that variable to get our marginal cost function as we have in this case. Hope that is clear. So let me take another example. So we know this rule already. So let me just explain this. So I want to take another example. Let's say I have a total revenue. Let me move to total revenue. And total revenue is given as let's say 2q raised to power 3 plus q squared. So let me write it down so that I won't need to write on two lines. Let's say we have total revenue, which is given as we say 2q raised to power 3 plus, let's say we have 4q, so I just change it, and we have 4q squared. Let's we now have minus 50q. Let's say this is our total revenue function. And if you are asked to derive marginal revenue from this total revenue, what do we need to do? So follow the general rule to get a marginal concept from the total concept, differentiate that total cost. To derive, what do we need to do? You just have to follow the general rule. To derive a marginal concept from a total concept, so we only need to differentiate that total cost. We only need to differentiate that total concept with respect to its independent variable. You can see here we have the independent variable here also used here is Q. So to derive our marginal revenue, so the rule says we should differentiate total concept. Which total do we have here? Is total revenue. Because we differentiate total revenue, so that means we are going to have marginal revenue. So in other words, we have the TR over the Q, then we differentiate. If we differentiate this one, bring down 3 here, multiply by 2, so that will give us 6Q minus 1 from the power, we have square. Then we have plus, bring down the power, multiply by the coefficient, 2 times 4, that is 8, then we have Q. Subtract 1 from the power, so that remains 1. Then we have minus, we differentiate this, so we have 50. So that means this is our marginal revenue constant. This is our marginal revenue function. So that is the rule. So let's also take another one. Let's say marginal product now. Let's say we have marginal product now. So let's say we have a total product. We use another example. Let's say we have a total product is equal to, let's say 3, and let's say total output depends on unit of capital, unit of labor employed. Let's say square minus 4L. Okay, as the case may be. So this is just an example. So what do we need to do? So to derive marginal product function, this is our total product function. Derive marginal product function. The general rule says that we should differentiate total concept with respect to the independent variable in the function. So the independent variable in the function is L here, which is the unit of labor employed. So in other words, our marginal product will be the TP over the L, which is equals to, we'll differentiate this, so we have 6L minus 4. So this is the marginal product function. Okay, what of utility? What of utility? Before we move to utility, let's take another example of this total product function. Let's say instead of depending on unit of labor, let's say total product depends on unit of capital. So let me just manipulate this. I say K, let's say K squared plus K. So in other words, to get the marginal product of capital, because it now depends on capital, so we are going to differentiate with respect to the capital. So we have marginal product of capital. The first one is marginal product of labor. don't forget. But this one is now marginal product of capital. I can just put it marginal product of capital. You can put K here to indicate that. So by the time I differentiate this one becomes 6K minus 4. So this is marginal product of capital. So I just have to differentiate that total to get the marginal function. Okay. Now, moving to marginal utility. Marginal utility. Let's say we have our utility function, our total utility function as, let's say, 6y squared minus 4y, okay, minus 4y maybe plus 10. And we are asked to derive our marginal utility function from this total utility function. So how do we do that? So the rule says we will differentiate this total utility function with respect to the independent variable. So the independent variable here is the unit of goods consumed, which is y, represented by y here. So in other words, marginal utility here will now be equals to the TU over dy, which is equals to 2 times 6, that is 12y, minus, differentiate this, you have 4. So constant here becomes 0. So the marginal utility function is this. Okay, so we apply the same thing to the rest. So 5, 6, 5 and 6. Okay, can you do 5 and 6 on your own? Let's say we have marginal expenditure. If you have marginal expenditure, so you can exercise. You can do that on your own. Exercise and tell me the answer in the comment section. So let's say we have a total expenditure then equals to, let's say we have 5. Let's say we have 5Q. Let's say we have 50 plus 10Q. Let's say this is the total expenditure. 10Q squared plus Q. So can you derive marginal expenditure from this function? So the second one, let's say we have, this is the first one. The second one, let's say we have consumption function. Let's say consumption function is equals to, let's say you have 20 plus 0.7y. Okay, can you derive marginal OPEX to consume from here? So tell me your answer.